Okay, so again, we're adding and subtracting fractions now. The same rules apply as before when adding and subtracting fractions. You need to get a common denominator. So looking at A, in A my denominator is 8x. In B, my denominator is 6x squared. If it was just the numbers, 8 and 6, what would you need to have as a common denominator? What numbers would you need to multiply? 48 would work. Do we have a smaller one? 24 is even smaller, right? Because we have to simplify in the end, so if we can find the smallest one, it usually works out the best. So for the first fraction, I can multiply the bottom by 3 and the top by 3. I'm going to put the top in brackets because it's going to get distributed. And the second one, I need to multiply the top and bottom by 4. That would give me 24. The numbers would be the same. Next, I look at my variables. Under the first fraction, I have an x. Under the second fraction, I have an x squared. So what do I need? I need an x in my first fraction. What does that give me? That gives me 24x squared and on the top I would have 3x squared plus 15x plus, and on the next one I'd have 24x squared, and on the top I would have 4x minus 28. When you had fractions, once you got the common denominator, what did you do next? You add the numerators. So when adding our numerators here, my denominator stays the same, 24x squared. I'm going to combine my like terms. I would have 3x squared plus 19x minus 28. Okay? Temptation will be, can you simplify these x squareds? No. Right? You can only simplify if you're multiplying, and you can only simplify once things have been factored completely. So, for example, on the top, this is one big factor. Is there a common factor you could take out of it? 3 doesn't come out of 19. No. So we are done. Can't factor it. That's one big factor. The only way you could cancel it out is if you had that entire thing in your denominator. You cannot cancel just the x squareds. Because you can only cancel when you're multiplying and things have been factored. You can't cancel when things are adding. Okay? If you try to cancel when things are adding, 2 plus 8 divided by 2, is that equal to 8? No. It's equal to 5. You're not allowed to cancel those 2's. Order of operations don't allow you to do that. This is grouped together. First, you would have to do 2 plus 8 and get 10, and then divide by 2. The same rules for numbers hold for algebra. But sometimes when we're dealing with algebra, we forget our number rules because we're dealing with something that's abstract, and we get tempted to cancel and do things that are not allowed. Part B. Do we have a common denominator? Not yet. Again, I'll rewrite it out. 3c minus 2, that gets grouped together, minus c plus 8 over 5c squared d. This one's extra difficult because we're subtracting. Subtracting is much harder than adding. Okay, look at your numbers. 3 and 5. You'd have to get 15, so I would multiply this one by 5 and 5, and this one by 3 and 3. Look at your variables. The first one needs a c. Does the second one need anything? No. So now we have successfully got a common denominator. On the bottom here would be 15c squared times d. Second one will be 15c squared times d. If I distribute here, I would get 15c squared minus 10c, and here 3c plus 8. And now I'm going to make the mistake, don't write down the next line, I'm going to make the mistake that almost all of you will want to make. So, okay, are you ready? Watch and see if you can see where my mistake is. Okay, how do we subtract fractions? Well, we keep our denominator the same, so it'll be 15c squared d. And I subtract the top, so I'll get 15c squared minus 10 minus 3 minus 13 plus 8. I messed up. Don't say it out loud. All right. Oh, yeah. One of them was by accident. It should have been, when you distribute the 3, 24. So that's one mistake. And then this subtraction sign subtracts the whole fraction. You have to distribute. And so it needs to be minus 24. Okay. So 6, 7, and 8. You have 5 minutes to work on this.